Hi, my name is Rene with Holte Manufacturing, and we have designed and fabricated the system that you will see in just a few minutes. This is a job site located in Cedar Flats, Iowa, and the contractor is Schnabel Foundations. We're drilling in a sewer plant for the city. Basically, they're micro piles designed to hold down a clarifier. Right here you see the needed compressors. Those are two 1170 by 350 psi Ingersoll Rand compressors. You only need one of them, but in this case they're using two at times. Here again you see the drill bits just hanging loose. They're almost ready to start drilling. A reverse circulation system with the grout through technology. As you will see, here we go, we start drilling. You can hear the compressor run, and they're actually drilling through a layer of overburden consisting of gravels, some silt, and some just regular sand and so on. Anyways, if you will notice how fast the drill is advancing in this rather loose materials, it's pretty amazing. Pretty soon, of course, we're gonna have a rock formation to deal with. Right now there is about 15 feet of overburden to go through. In the next clip you will actually see where the reverse circulation really start paying off. Also notice there is no debris coming from around the drill stem, which is the same size as the drill bit, meaning no other casing is needed, because it will be retracted and cemented in as when the hole is finished. The size of this is 14 inches, equipped with a 14 inch down the hole hammer. Of course, reverse circulation. Right here again, we want to demonstrate how clean the drilling site will remain when you use the reverse circulation system. There is no debris coming from around the drill stem, basically, and it keeps the job site very clean. If you see in the background, there's a steel plate, and the steel plate is there because the ground was so soft and the heavy machine was actually kind of sinking, because we're already dug down 10 feet from the surface. So, and there is a lot of water in the ground, so there was steel plates needed to hold the machine up. Again, notice the speed of the drill advancing. Right now we're drilling in a rather soft rock, anywhere in the neighborhood from 75 to maybe 85, 100 megapascals. In other words, maybe rather at 8 to 10,000 psi. Not a very hard rock, but highly broken and fissures in it, so there is a lot of circulation in normal circumstances, which you won't have here. All the cuttings are going up through the middle of the drill stem, and on the left hand side you see a flex tube hanging. That is the cutting discharge, which you will see it in a few minutes. Okay, here's a good view over the modified 275S drive head on the Bauer BG28. As you notice, the cuttings are going straight through the middle, up through the drive head. Also notice the drive plate on the bottom being bolted on. Here's the discharge cutting, square plate on top, which is removable for wear purposes. Okay, here's a mud pit dug to collect all the cuttings, and it discharged in an open-ended bottom box, as you can see here. And from there on it just flows into this pit and will be later excavated and hauled off-site. Here's a better view of the whole system. This box is not necessarily the only thing that can be used. We can be using anywhere from a cyclone to boxes to trucks, any which way, or any means of discharging and collecting the cuttings. As you can see, the drill stem and the dry bit, the drill stem is all of the same size as the drill bit. In this case, again, it's 14 inches, but it can be 18, 20, whatever size hole needs to be drilled. Here's another view of the discharge box. If you notice, the air coming out of the two holes that have been cut in the side. So there's no cuttings, no mud flowing on the drill side itself. Very well contained. Again, a side over the drilling. Notice that there is no cuttings coming from around the drill stem again, which will keep the drill side very clean. As you can see, again, the drill side is kept very clean. Again, a little view over the dry bit. Notice that it needs to be turning very slow. We're looking at around 4 to 5 RPMs maximum. The drill bit is designed to penetrate on a hammer basis, not like a tricone that has to be cutting with teeth. Here again, you will see the hole has been finished with the F2 depth, and now you're retracting the drill stem and pumping the cement at the same time. Inside the operator's cap is a gauge that will monitor the pressure needed for the grouting system. As you can see, it keeps pulling. When it loses pressure in the cap, it will actually stop till the pressure starts building back up. The pressure runs around 8 to 10, maybe 11 psi. If the pressure drops, in this case, right now, he stopped waiting for a void to be filled. As the pressure builds back up on his gauge, he will start retracting more and tries to keep right around 10 psi till the whole drill stem is retracted out of the hole. This process can take, depends on the voids in the rock, of course. This process doesn't take that long. And the operator, there's an operator that runs the cement plant that keeps track of the right mixture and so on. You can see they're cleaning out the drill bit after the cement they retracted from the hole. They're just blowing all the cement out and mixing it with water. It's very essential that you have all that stuff cleaned out, because if you let it harden in the drill stem, it would not be a good thing. We have had some hammers that we had to clean out after they let the cement dry, and you risk losing the hammer altogether. Also worth mentioning is that the hammer is equipped with check valves preventing the cement from going into the hammer's air supply channels. After the cement is gone, they're flushing it with water and make sure that it's pretty nice and clean, ready for the next hole. Okay, here the cemented hole will be, in this case, they're going to insert a 12-inch casing, full depth, and it's just in an open hole, cemented in, of course. and they just sink the casing to where they need to be. Notice the stabilizers on the casing to keep it in the center of the hole. Now they're going to have to check for verticality. And now you will see the cement coming out of the hole because, there you go, they're down to where they need to be. This casing is lowered with means of, they have a small crane on site. Inside the steel casing, they lower a bar with a threaded end. Here's the finished products after they clean the cement from around it. And they're going to have to do some excavation, of course, and clean up after the job site is done. But you can see the finished products, and in the background you see a piece of cement that was cut away from around the steel casing. In all, there were 160 piles drilled in a very small area. As you can see, they were all close together. Basically, there is no air loss in the soil with reverse circulation. This was just a short overview of what reverse circulation can benefit you in many ways over conventional drilling. Thanks for your attention.